All right, level 1, number 6. And of course, this is the one that deals with this idea of efficiency. So what I'm going to do is just give you a little brief rundown on what efficiency is. Maybe I'll prepare a video for the actual LMS lessons, but for today we'll just do it here. So what is efficiency? Well, in grade 9 you actually talked about efficiency when you were doing electrical energy. And so efficiency is a comparison, basically. It's a comparison of the useful energy out divided by the energy input, or the energy in, right? Maybe we should put the total energy in. And so what does that actually mean? Well, that's the trick. We have to figure out how do we determine what is useful energy out and what is the total energy in. So we can think of it like this. The top of that, the useful energy out, is what is actually accomplished. Okay? What is accomplished? And by is, I mean what energy change is accomplished. And then the bottom is, how is it done? How was this done? So in this particular question, we have a motor, and it's using 16,000 joules of electrical energy, and it's accelerating a 200 kilogram moped from 10 meters per second. Okay. From rest, 10 meters per second. So let's see what we have here. We've got an energy of 16,000 joules, right? And then we have a mass of 200 kilograms. I better put my units in there. And then we're going to go from a V1 of 0, rest, and a V2 of 10 meters per second. Okay. So this 16,000 joules was the energy that was used, right? It was the energy that was put into the moped, or the motor. Yeah, it's a moped motor. So this is the top number of our expression. The useful energy out, or sorry, it's the bottom number, my mistake. The bottom number, it's how it was done, right? This was accomplished by putting in this electrical energy from the motor. But if we look at this other information, we can also get an indication of what the top would be, right? What did we actually accomplish? Well, what we accomplished was we sped something up. We sped up a moped. Now, if you change speed, changing speed means that we have a change in kinetic energy. Basically, in this course, we talk about two kinds of energy, right? Gravitational energy and kinetic energy. Kinetic energy is all about speed, and gravitational is all about height. So if you're changing height, right? If you had a question where you were changing height, like sometimes they'll say, you know, you're lifting something up. If you're changing the height of something, then you're talking about a change in gravitational energy. All right. But in our case, it's a change in speed. So let's look at that change in speed. What we can say is, well, let's look at the change in kinetic energy. The change in the kinetic energy would be EK2 minus EK1. That's how we do all changes in science, right? So we can write down, okay, well, kinetic energy is 1/2 mv squared, so we'll use a 2 here, and 1/2 mv squared 1, the first speed and the second speed. That's the change in the kinetic energy. That's essentially what we accomplished. It's the top of this expression. And so let's look at it. Well, we can simplify this a little bit before we dive into the math. We can pull out this 1/2 and this m as a factor and get this. Or you can just shove the numbers in up top if you want. It doesn't really matter. But when we put in our numbers, then what we get is a mass. Let's see, it was a 200, right? 200 kilograms. And then we have this V2 squared. Well, it was sped up to 10, so that's 10 squared. and from rest. So what we get is a half times 100, 200 times 100, right? So that's 1/2, 200 times 100, a half of 20,000. So that's 10,000 joules. So what this means is if you were to take this moped and you were to speed it up from rest to 10 meters per second, you would have to change its kinetic energy by 10,000 joules. In other words, that's what you would have to that's what you would get out of it. That's what would happen to this moped, right? Its energy is changed by 10,000 joules. So what we did is we used 16,000 joules of electrical energy. But you'll notice that all we really accomplished to accomplish a change of 10,000 joules of kinetic energy. Now, why is that? Well, some of the 16,000 joules would have been wasted through friction in the engine and heat and sound and other kinds of wastes. You'll remember that in one of our videos we talked about work and power and energy and the types of energy and how energy transformations always have some waste. So it was not a perfect trade, right? We lost some here. If you had to spend $16,000 to make $10,000, that wouldn't make much sense because you lost money. But in the world of energy, there's always a loss. So if we want to calculate the efficiency, then what we do is we take, go back to here, we take what we accomplished, which was effectively the change in kinetic energy, right? The change in the EK, and we divide that by the whatever it was that we had to put in, and that was the 16,000 joules of electrical, I'll call it EE, electrical energy. And our number, of course, was 10,000. So now you can see how we just do the efficiency by saying 10,000 divided by 16,000. And sometimes people will multiply this by 100% just to put it in percent form, right? But you can do it as a decimal form or a percent form. It doesn't really matter. It's just a comparison. So that's how efficiency works. You would have done this in grade 9 using the efficiency of, say, a light bulb, and you would have said things like, you know, if you put in 200 joules of electrical energy and you get out 150 joules of light energy, and then you would have done this kind of a comparison in that sense. At least you should have. Maybe you didn't. But that's how efficiency works for this question, right? And the whole trick is trying to figure out just what these two things here mean. What is that accomplished energy change? And I'll give you a hint. It's usually going to be, for us, a change in kinetic energy or a change in gravitational energy on top. And then on the bottom is what you did to make it happen.